So for the following system of equations in echelon form, so tell how many solutions there are in non-negative integers. So how many solutions are in non-negative integers? So here the non-negative integers mean non-negative integer. It means that so your x and y and z, so they all should be greater or equal to 0. None of them could be negative, and they should be integers. Each of them should be integer. How many solutions are there? So for example, this is really easier to do it. So one way is like, say, you write on this echelon form, right? So you can write on from the first equation. Let me write it here. So x minus 5y plus 8z is equal to 60. And second equation is like, say, 2y plus 5z is equal to 44. And you see that there are three variables in this one, right? So x, y, and z, but there are two equations. Whenever there are more variables than equations, so then it can have infinite many solutions, right? So more than one solution. So, but it could have infinite many solutions, but we have restricted ourselves to only non-negative integers here. So non-negative integers, so it means that when we restrict ourselves here, so its solution could be finite number of solutions, could be 1, 2, or 3. We just keep us that x, y, and z, all of them non-negative integers, right? Mean that their values could be like 0, 1, 2, 3, 4, 5, so on, like that one. So to do that, so first of all, solve this for y second equation. So then from here, so 2y would be equal to, so negative 5z and then plus 44. So divide by 2 on both sides, for example. So divide by 2, so this divided by 2, this divided by 2. So you get, say, y is equal to negative 5z by 2 plus 22, right? Or if you want to write in the same denominator, so that is 44 minus 5z by 2, right? So 44 minus 5z divided by the common denominator, right? 2. So either in this way or this way, right? So it doesn't matter. And now from here, so you can also solve this for x. So from here, so x would be equal to this equation. So move 5y and 8z on the other side. So that would be as a negative 5y. Other side it become plus 5y. Then minus 8z and then plus 60. And now from here, so y value, you can plug in this y value, right? So this part here, right? Plug in this back in here, right? So this one, so go back in here. So your x would be 5 times, so that is 44 minus 5z divided by 2, and then plus, sorry, that's minus. So minus 8z plus 60. So this would turn out to be like, so 5 times 44 divided by 2, so it would be 44 divided by 22, so 110 minus, so 5 times 5 is 25, so negative 25 by 2 z minus 8z plus 60. If you simplify this one, so 60 and 110 is 170. And then minus 8z and minus 25 by z. So minus 8, if you make it a common denominator, that's negative 16 by 2. So that would turn out to be like negative 16, negative 25 is 41. So negative 41 by 2 z. That simplify into this. So let me rewrite this one. So this equation would be like, say, so x is equal to negative 41 by 2z plus 170. And y is let me write it here. So negative 5 half of z plus 22 and z is equal to z. So let's start. Okay, so now we have to check that how many solutions are there. So, and we are given that x, y, and z, they should be non-negative integer. It's given here, right? So we are given that, so they are non-negative integers. So they should be non-negative integer x, y, and z. And see that we would get like say 9 solution or like say A or B or C or D, which choice is correct. So we have to figure this out now. To do that, so now from here, this x and y and z, so we have to figure it out. So let's say z is equal to 0. When z is 0, so we would get what? So y would be 22, right? This would be integer, positive integer. And then x would be, so when z is 0, so this part is 0, so 170. Right? So this is one solution. All three of them are integers, non-negative. So next, say let z is equal to 1. For example, if z is 1, for example, so then here from here it would see what? So this negative 5 by 2. And 22 minus 5 by 2, so y would not be integer, right? That would be a real number because it would be 22. For example, let me do it here. So y would be, so negative 5 by 2 plus 22. So negative 5 by 2 is negative 2.5. So that would be 19.5. And this is not an integer, so this would not count, right? So it means that this z value would not work. Actually, if you see that z, the denominator is 2 in both places, so in order for x and y to be integers, so this z must be multiple of 2. So it means that this is not a solution, required one. So we go with the z as a multiple of 2. So when z is 2, so from here, y would be, so negative 5 times 2 by 2, so that gave us negative 5 plus 22. So that gave us 17. And similarly, so x would be then, so negative 41 times 2 by 2, so that is negative 41 plus 170. So that gave us like another integer. So that's 9 and 2 and 129. Similarly, then you go with the 4 and then go with the 6 and then go with the 8 and then go with the 10 and then check. So for example, let me see if z is 10, for example. So if z is 10, so what would be y here? So y would be, so negative 5 times 10, negative 50 by 2, so it would be negative 25 plus 22, negative 3. So you see y got negative, it means that, so this would not work, okay? So we should have to be below this one. So z is equal to 8, for example. If I go with 8, so 8 times negative 5 is negative 40. So negative 40 by 2 is negative 20. Negative 20 plus 22 is 2. So y is equal to 2. And similarly, so x would be, so is 8. So negative 41 times 8 by 2 plus 170. So that would be equal to, so 2 times 4 and 4 times this would be, so negative 164 plus 170, so that would be equal to 6. Right, so this would work. So it means that it would work until you reach to the z is equal to 8. So you do not have to actually compute everything. So when you see that it stopped working at z is equal to 10, we are getting a negative integer, so we don't have to then go there. So it means that it would work when z is 0, when z is 2, when z is 4, when z is 6, and when z is 8. So number of solutions would be 1, so 2, 3, 4, and 5. So number of solutions are 5. So 5 solutions.